Now I would like to welcome our next speaker, Mehak Mushtaq Malik. Mehak Mushtaq Malik is a dedicated research scientist, and she is pursuing her second master's in artificial intelligence from the University of Cyprus. Mehak, now you can present your speech.
Hello everyone, and thank you for having me being there. Thanking especially Dr. Inam and other organizer who make this event possible. Now I'm sharing my screen. I hope it will be visible. So, my name is Mehak Malik, and I am from Pakistan but currently residing in Cyprus and doing my master's in AI. And my specialization are basically related to AI, computer vision, machine learning, deep learning, robotics, adversarial attack, and localization. The topic I am presenting here is basically belongs to cataloging of multiple chronic disease using hybrid deep CNN model and entropy coded sine cosine optimization. Basically, the topic is from related to plant. I was working on the detection of disease in the plant, specifically in the corn plant. So why I did it because primarily grain and dominant crop is corn in the world, and more than 90 million acre of land is used for the crop growth. So as you know, we say that agriculture is the backbone of the country economy. So as we know that vegetable and crops are used in both human and livestock need, and when we have a disease outbreak in the crop, we have to bear a loss of heavy loss. So we have to detect the disease, detection at prior to the time. So we will cure the disease, and we will avoid major loss in the crop. And so for this, we have required to do early detection to control over disease. So what was the motivation to do this research? Is basically I was in contact with different pathologists. They rely on the symptoms to diagnose disease. Actually, we do manual detection as we see that farmers are doing manual detection, and they took the step to avoid that disease. But if they have very large land, then it is almost impossible to detect every single disease in the whole plot of the farm. So $40 billion economic loss was there in the US last year. It's the statistical analysis. And we are seeing that the population is rising. So we think that there is a demand of food which will be increasing in the next 40 years due to the population rapid increase. That is the statistical analysis of the National Center of Biotechnology Information. So, in my topic, the main contribution I did is basically related to CNN technique. I proposed the TreeNet CNN model for the feature extraction. Then there was required analysis of interclass similarity and intraclass variation of corn leaf images. At the end, recognition and classification was the main task of my research, and the most important task is to compare my results with the previous one, where I made a borderline, and I made a target of accuracy and classification, which I have to maximize my result, and my result must be better than the previous one. So that's my proposed methodology and my work where I did research work. So it's basically based upon first I have to do a pre-processing of the, I have data set which has 4 classes, and they are like disease and healthy classes. So then I did pre-processing on them. There was color spacing and converting RGB to YCBR. You know, RGB is basically red, green, blue images to convert yellow, prominent blue and prominent red color. So they actually enhance the images. So it will be better for the later classification. And for the in the pre-processing, we also did data augmentation, and we did horizontal and vertical flipping as well. In the next stage, we did feature extraction, where we use already defined CNN model like densenet and darknet. And my proposed treenet is also used for the extraction feature from corn dataset. Then we get the features from these three models, we fuse them, and then we later use it for the feature selection, where we choose 1400 best features using sine cosine algorithm, and at the end we put those best features for the classification purpose. So that was results. When I did comparison of results, I got idea that I use different classifier like SVM, KM, and many other. I realized that my medium Gaussian SVM got accuracy of 99.8%, and I did that processing on the dataset of Kaggle. The previous most advanced work was done on AI based on plant disease detection, which was based on CV and also on the Kaggle dataset, and their accuracy was 96.54%. So that's the reference, and if someone has any question, please let me know.
Do you have any question? I don't think we have any question right now.
Thank you so much, everyone, for hearing me.
Thank you, Mehak. Thank you for your time and speech.